In this section, we're going to talk a little bit about some of the characteristics of these covalent compounds we've been talking about. One thing that I've mentioned a few times, and I want to expand on that a little bit, is electronegativity. Electronegativity is basically how strongly an atom attracts the electrons in a bond. And so it tells you how much stronger one may pull that electron towards itself than another. And so the electronegativity is high and right, okay? So high and right, okay. High and right, okay? And so what that means is the farther right and high you go, the stronger the electronegativity. And in the world of electronegativity, an F is a perfect 4.0, and so it is the strongest electronegative atom on the periodic table. So fluorine is the highest and rightest because, you know, these noble gases don't really play a lot. So that is the most electronegative. So anything to the left of that or lower than that is going to be less electronegative as you go. All right, so fluorine is going to attract those electrons more strongly than anything else. So if the electronegativities of two atoms that are bonding together are equal, then it is going to have what we call a nonpolar bond. So if you have two carbons that are connected together, they're the same. So they're going to have the same exact electronegativity. In this case, it's 2.5. And so that is not going to create one being stronger than the other because they're going to be attracting with the same force, if you will. And so we call those nonpolar. If you look at carbon and hydrogen, okay, carbon has a 2.5 electronegativity, hydrogen has a 2.1 electronegativity. There's a very small difference between those. The difference is actually 0.4, and that's the cutoff for where we really start saying that it's nonpolar versus a polar bond. So the electrons in the bond that are being shared equally or close to equally between those two atoms is going to create this nonpolar bond. Now, a lot of times in bonding, you're going to have a difference, a pretty large difference. If it's greater than 0.5, then we say that it is going to be a polar bond. And so again, we can look at the differences in the electronegativities. When that happens, then this polar covalent bond, it creates what we call a dipole. Two poles, okay? So we have a positive end and a negative end in this bond, okay? So we call that a dipole, or you might see it called a dipole moment. And so since there is a big enough difference between a carbon and an oxygen, the oxygen is more electronegative, then we form a polar bond between those two. Okay, so the electrons are unequally shared, and what that tells us is this end that the oxygen is on, since it's more electronegative, is going to be pulling all the electrons that are being shared closer to it, and therefore it is going to have a more negative end to that bond than on the carbon side. So the electrons are pulled towards the oxygen more. And so it's not really strong enough to be an ionic charge, so we call it a delta negative or a partially negative charge. The electrons are pulled away from the carbon, so since it's the less electronegative element, and so this is the way we show that. Since one end is being pulled more, then that's the partially negative end. If you've got a partially negative end, the other one has to be partially positive. And so if it's less than the 0.5, so if it's 0.4 or less, then it is nonpolar. If the difference in electronegativities is 0.5 to 1.9, then it's a polar covalent bond, okay? If it is greater than a 1.9 difference, that's when we see it's strong enough so that it pulls it so strongly that it pulls it completely away. So we have a transfer, and that's when we have an ionic. Once we've done that, we created polarity. Okay, so if we have a polar bond, that is a partially negative end, partially positive end of a bond, then we can have a polar molecule. And the polarity of these individual bonds is going to define the shape of the molecule. Nonpolar molecules will have no polar bonds, or they'll have dipoles that cancel each other out. So you see this with, like when we said you have two things together, they're going to basically be pulling those electrons with the same amount of force, and so they cancel each other out. Polar molecules, though, are going to have at least one polar bond, and the dipoles do not cancel. All right, so the dipoles do not cancel. So usually we look at this and we say that the molecule is not symmetrical. Okay, it's not a triangle, it's not a square, it's not a tetrahedron. Okay, so if it's not, then it can be a polar molecule.